2016 has been an eventful year for ESA's ExoMars mission. It has been one of multiple successes and one unexpected setback, but it is ending on a positive commitment to the future of European science on Mars. Ministers from ESA member states have agreed to continue funding the next stage of ExoMars, a second mission which will include a robotic rover, a first for Europe and the first rover that will search for signs of life below the planet's surface to a depth of 2 meters. The mission will build upon the findings of ExoMars 2016, which arrived at Mars in October after a 7-month journey. The ExoMars Trace Gas Orbiter has now tested its instruments in orbit. The calibration measurements and health checks demonstrated that the orbiter is on course for a successful mission. The present orbits around Mars take just over 4 days, and distances above the surface vary from 100,000 kilometres to just 230. The Atmospheric Chemistry Suite, ACS, and the NOMAD instruments will be measuring gases in the atmosphere, including methane, nitrogen dioxide, acetylene and water vapour, trace gases that make up less than 1% of the atmosphere. Methane is especially important, as on Earth it is associated with biological activity or with certain geological processes. All the instruments, including the neutron detector FRIEND and the colour and stereo imaging system CASSIS, performed extremely well during the testing period. CASSIS has also sent back its first 11 images during a close flyby. It produces colour images by taking 4 simultaneous images at panchromatic, red, near-infrared and blue wavelengths. Its closest approach was 235 kilometres from the surface, north of the Valles Marineris canyon system. This image shows a crater 1.4 kilometres across, near the rim of a larger crater near the planet's equator. And this interesting formation is on the side of a large volcano and reveals pit craters. The image width is about 25 kilometres across. The camera team also produced a 3D reconstruction of a region using a stereo pair of images, showing everything is working as it should be. All the data collected during these tests will help improve the onboard software to produce even sharper, higher quality images in the future. Unfortunately, as with many missions to Mars, the technology demonstrator lander Schiaparelli fell short of its goals. It collected almost all of its expected data during its descent on October the 19th, but the craft crashed onto the surface during the last minute before landing. The precise cause is still being investigated, but preliminary technical investigations have found that the atmospheric entry and slowing down in the early phases went exactly as planned. The parachute also deployed as expected, and the heat shield was released correctly. During the next phase of descent, however, erroneous information was passed on to the guidance and navigation control system for just 1 second. When merged into the navigation algorithms, it generated a false altitude of below ground level. This triggered the release of the parachute and the back shell prematurely. The braking thrusters fired briefly and the on-ground systems activated as if it had landed, but the lander was still 3.7 kilometres above the surface. Crucial lessons will be learnt from this for the 2020 ExoMars mission. The Trace Gas Orbiter will start aerobraking in March to gradually slow down over the following months. By the end of 2017, the orbiter will be in a lower, near-circular orbit of 400 kilometres, and ExoMars' primary science mission can begin.